This is Jacob Welgus,
And Anthony Battaglia.
and this is our OS Project 03. Begin with a make clean, and then we'll run our tests. Finished building.
And as these tests are running, we'll point out, as you can see in the little testing of the timing, first fit is easily the fastest of the three, where best fit and worst fit are about or take 2 times as much time. Both of them about equal to each other. But
Yeah, and in order to, during our analysis of the three different algorithms, we also noted that first fit tends to be pretty similar to best fit in terms of the number of the fragmentation. This isn't the most clear here, which is testing du/lib/. However, what you can see from this is if you look at best fit, which has a heap size of around 38,000, and you look at worst fit, the heap size is much larger at about 400,000. So worst fit tends to have the biggest heap size, and in terms of fragmentation, as previously mentioned, seems to be pretty much best fit as a winner, first fit not far behind, and worst fit very far behind.
also, I think actually misspoke, 387,000 for best fit.
Yes.
38,000. Yeah.
Yes.
I would say worst fit is worse, but not by like that much. Yeah. And then yeah.
And then in terms of errors, you don't see them here, but some of our tests do not work on other student machines. Seems to be pretty evenly split which student machines. The culprit is this DU right here. It for some reason causes a memory error where it runs out of memory and it exits with exit code 1. We're not sure if the different student machines have different maximum heap sizes and that's what's causing that, but in any case, we do have that single error.
No, the tested student machines were 05, 10, 11, 12, and 13. It works on 12 and 13, does not work on 05, 10, or 11, but yeah. And then also it does run out of memory. It runs out of virtual memory if you try to do like a tree of too big of a structure. Another thing we were just playing around and testing with. But also, if you wanted to see the displayed difference in fragmentation a little bit better, you can just look at the like run test in the bin, and that'll show a little bit. Also, like similar to the DU stats we had, it'll also show some of the stats we use to make our deductions.
Yep. And then in terms of what we learned,
and then the other quirk about our global.
Oh, well, that's not so much a quirk, but one thing that's different about our program is if we go into, we're in the wrong thing here, if we go into block.c, you can see that instead of calling sbreak in, where's release? Instead of calling sbreak in block release, we instead use a global heap pointer, which is maintained every time we release and every time we allocate. So you can see here in allocate, when we first allocate, and when we allocate every time after that, we make sure to update the heap pointer. The heap pointer starts at null, but since you don't release until you've already allocated something, that's not a big deal. It'll get set before it ever gets read. And we believe that this probably saves us a bit of time since we're doing one less sys call every time we free, because usually every time we free there would be a sbreak 0 here. But we got rid of that by making this one small optimization.
Yep.
Then, now what we've learned, we learned how to make a custom malloc, which, as it turns out, is something that is regularly done in real life, which isn't something I was aware of. I also learned how to use GDB when I was trying to debug on student 11 with the previous error we mentioned.
I learned how to implement the worst fit, best fit, first fit, and also kind of what they might be used for. Yeah, I also learned how to inject my own version of a standard lib thing into something by doing LD preload.
Yeah. And I think that would be all.